Hi and welcome to video 4 in this video series on differential equations, Unit 4, Topic 2, Specialist Mathematics. This video we're going to look at specific differential equations in the form dy dx equals a function of y, which we're calling g of y because we've used f of x. So let's have a quick look at how this looks. And we're going to use that sort of formatting that we learned in an earlier video. So if dy dx equals g of y, some function of y, might be y squared, might be sine y, whatever it is, well then dy dx equals g of y times dx, so dy equals g of y times dx, and then 1 over g of y dy equals d of x. And then we can integrate both sides, and we've already got the dy and the dx in the right place, and of course the integral of dx is the same as 1 dx, and we get x is equal to the integral of the reciprocal of that function g of y dy, and often the result can be rearranged such that y is a function of x, which is usually what we prefer, where y depends on x. But, you know, who knows, depends on the situation. So let's have a look at an example. Find the general solution to the differential equation. I've gotten a bit lazy here. D dot E, dy dx equals E of y. So the general solution to this will be that dy equals E of y dx, and therefore 1 over E of y dy will equal dx, and we can integrate both sides to get this, and it's equal to the integral of e to the negative y dy, and that's equal to the integral of 1 dx, and then we get this, e of negative y over negative 1 plus some constant equals x. Or we could put the constant on the x side. And this is a general solution, so I'll just quickly show you where this might lead. E to the negative y equals x plus c. Now this is important to recognise. It doesn't really matter how we treat the constant. The constant there is negative 7. It just becomes positive 7 here, but we haven't still classified or worked it out. And then we can rearrange this as well. So we get something along the lines of e to the negative y equals c minus x. It's important that the x is negative but not the c, and take some time to think about that, but I'm going to keep on doing that type of approach and keep my c as simple as possible. Negative y equals log of c minus x, and therefore y equals negative log of c minus x, and that's about the best I can do for that particular question, so I'll leave it in that form. And that's the general solution because I don't know my c value. Now let's have a look at example 6. Find the particular solution of the differential equation there at x equals pi on 4, given that at x equals 0, y equals 3. So this is leading to a particular solution, and would you believe it, we've got a little bit of a pi on 4, which obviously gives us a bit of an impression that there might be some trig involved. So let's see how we go. So I get swapping y squared plus 9 on the bottom dy equals dx, and then I can integrate both sides. And when I integrate both sides, I get over here the nice x plus some constant, but over on this side I get the integral of 1 over y squared plus 9, and I loosely remember somewhere that that had something to do with tan inverse, and I look at my formula sheet, it's tan inverse, and in this case y over 3, and I get a third factor at the front as well. And there's my derivative. Now, it might be more desirable to me, particularly since I'm given an x value, to find y in terms of x. And this doesn't take a lot of work. Tan inverse of y over 3 is equal to 3x plus 3 times c, which is still just some constant. And therefore, y over 3 is equal to tan of 3x plus some c value, and y is equal to 3 tan of 3x plus some c value, and we prefer dealing with tan than we do with tan inverse anyway. We also know that at x equals 0, y is equal to 3, and so we get 3 is equal to 3 tan of 3 times 0 plus c, and so we have tan of c is equal to 3 divided by 3, which is 1, and so therefore c is equal to pi on 4, or negative pi on 4, or 3 pi on 4, whatever, but basically it's just a phase shift to the same function shifted enough to look exactly the same. And so therefore y is equal to 3 tan 3x plus pi on 4, and we'd like to find the particular solution at x equals pi on 4, and so we say y is equal to at x equals pi on 4, y is equal to 3 tan 3 pi on 4 plus pi on 4, which is 4 pi on 4, which is pi. So we get 3 tan of pi, which is 3 times 0, so that's 0. And there we have it, a specific point at x equals pi on 4, y equals 0, and we're finished. All the best.